Hello friends, welcome to Bindu Dhadwal chemistry lessons. Today's topic is Pauli's exclusion principle and distribution of electrons on the basis of quantum numbers. We will also solve some questions based on quantum numbers. Now, after studying the quantum numbers, we must now aim to distribute the electrons in different shells, subshells and orbitals. So Pauli in 1925 gave the Pauli's exclusion principle, which states that no two electrons in an atom can have all the four quantum numbers same. So two electrons present in an atom can have a maximum of three quantum numbers same. That is, they can be present in the same shell, same subshell, same orbital. However, they must have opposite spins. That is, the spin quantum numbers are different. For example, let us consider the two electrons present in K shell. That is the first shell. For them, the different quantum numbers are n is equal to 1 for the first shell. L will be n minus 1. So 1 minus 1, 0. ML is from plus L to minus L. So L is 0, so ML will be 0. And in the ML orbital, the electron may either move clockwise on its axis or anti-clockwise. So it can have, if one electron is having spin quantum number plus half, the other is definitely going to have different value minus half. So spin quantum number is different even when the principal shell, subshell and orbital are same. So let us learn the distribution of electrons on the basis of quantum numbers. So first shell is K shell. For K, the value of principal quantum number n will be 1 and L is n minus 1, so it is 0, and this subshell is called 1s subshell. So the type of subshell is S. Now the magnetic quantum number ML is 0. Quantum number can be either plus half or minus half. So how many electrons can be in the S subshell? Because there is only one orbital, electrons will be 2. And total number of electrons in this shell will also be 2. Then we have the L energy level. For this, the value of n is 2. And for 2, the L values can be from 0 to n minus 1. So from 0 to 1. So one value is 0. This is the 2s subshell. And the other one is 1 is the 2p subshell. So name of subshells are S for 0 and P for 1. The value of ML can be from plus L to 0 to minus L. This is 0, so value of ML will be 0. But for 1, the value can be minus 1, 0 and plus 1. Spin values can be plus half and minus half. So 2 electrons having these values. Similarly, for minus 1, you can have 2 electrons, one with plus half, another with minus half. Then again plus half and minus half, plus half and minus half. So there are 3 p orbitals in the p subshell and 1 s orbital in the s subshell. So electrons in the s subshell will be 2, whereas in the p subshell will be 2 plus 2 plus 2, 6. Total number of electrons in the energy level will be 8. Now next is M energy level. Principal energy level is M. So for this, the value of N will be 3 and values of L can be 0, 1, 2. 0 is S and for S the values of ml will be 0 only, and S values will be plus half and minus half, plus half and minus half. For P, ml values can be plus 1, 0 and minus 1. For D, for 2, L is equal to 2, ml can be minus 2, minus 1, 0, plus 1 and plus 2. For each of these, the spin values can be plus half for one electron, minus half for other electron. And total electrons will be electrons in subshell, in S subshell will be 2, in P will be 6, and in D there can be 10. For 5 orbitals there can be 10 electrons. So in all, in the M energy level, there can be 18 electrons at the maximum. Similarly, if the value of principal energy level is N, then N is equal to 4, L is equal to from 0 to N minus 1, so this can be 0, 1, 2 and 3. So for 0, the name of the subshell will be S. For P, for 1 it will be P, for 2 it will be D, and for 3 it will be F. For S, the value of ml can be 0 means 0, 1 means minus 1, 0 plus 1, 2 means minus 2, minus 1, 0 plus 1 and plus 2, from minus 2 to plus 2. Then for spin quantum numbers, each one will be having two values, plus half and minus half. Same for minus 1, for 0, for plus 1, for minus 2, for minus 1, 0, plus 1 and plus 2. Electrons in S subshell there can be 2 electron, in P there can be 6, in D there can be 10 electrons. Then for 3, this is F subshell, and the values can be from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. For each of them the spin values will be minus half and plus half. So for all the 7 we are going to have these spin values. Total number of electrons in the F subshell will be 14 for L is equal to 3. So total electrons will be 32. There can be a maximum of 32 electrons in the 4th energy level. So this is how you distribute electrons on the basis of quantum numbers. So let us now solve a few numericals or problems based on quantum numbers. The first one is questions based on quantum numbers. An atomic orbital has n is equal to 3. So what are the possible values of L? You know, for n is equal to 3, L values can be from 0 to minus 3 minus 1. So values of L can be 0, 1 and 2. Similarly, next question, an atomic orbital has L is equal to 3. What are the possible values of ML? So ML can be from minus L to 0 to plus L. So these can be minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So there are 7 orbitals. Next question, using S, P and D notation, describe the orbitals with the following quantum numbers. n is equal to 1, L is equal to 0 is 1s. When the value of L is 0, the subshell is S subshell. N is equal to 2, L is equal to 0 is 2s. L is 0. N is equal to 3, L is equal to 1. So when L is 1, it is P. So the name of the orbital will be 3p. N is equal to 4, L is equal to 0. So it will be 4. For 0 it would have been S, for 1 it would have been P, for 2 it is D. So the notation will be 4D. Next question. From the following sets of quantum numbers, state which are possible. Explain why others are not possible. The first is n is equal to 0. Now the minimum value for n is 1. There is no 0 value. So this is not possible. We don't even have to look into other values. Then second, n is equal to 1, L is equal to 0, ML is equal to 0, S is equal to minus half. This is surely possible. This is possible. The shell is 1s. Okay, third, whether it's possible or not, n is equal to 1, L is equal to 1. No, we cannot have L is equal to 1 because L is n minus 1. This is L is equal to 1. This is not possible. L cannot have the value equal to that of n. It is always less than n. Then fourth, n is equal to 1, L is equal to 0, ML is equal to plus 1. ML can have values from plus L to 0 to minus L. So L is 0, ML can be 0 only, not plus 1. So it is also not possible. An electron is present in the 4f subshell. Write the possible values for all the quantum numbers. So let's do. We have to write down the value for n, for L, for ML and for S. When n is equal to 4, L can have values 0, 1, 2 and 3 up to n minus 1. Now ML can be 0. For 1 there will be 3 values, minus 1, 0 and plus 1. And for 2 there will be minus 2, minus 1, 0, plus 1 and plus 2. For 3 there will be 7 values, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. And the value of S for each of these will be, for 0 there will be plus half and minus half. Similarly, for this you will have plus half, minus half, plus half, minus half, plus half, minus half. Then 5 times each orbital will have 2 electrons, one having plus half, one having minus half. Similarly here. So you can write it here. This is how you can find out all the possible values for all the quantum numbers.